All right, 9.4, we're going to be graphing sine and cosine functions. So we're going to talk a lot about like the vocab that goes behind it, but these are two kind of parent functions of our sine and cosine graph. They're super similar. If you notice, they almost look exactly the same, but the one difference is that the sine graph, so our graph on top, starts at 0. So sine graph starts at 0. Versus the cosine graph, the one on the bottom, here it starts at 1, but that number is going to change, so we're going to say it starts at the amplitude. And we'll talk about what the amplitude is and how we find that. So on the next page is where we have most of our vocab. So the domain of each function for both sine and cosine is all real numbers. So it goes forever in the left direction and forever in the right direction. Notice these arrows, our graph just continues that same shape, forever in the left and forever in the right. So that's why our domain is all real numbers. Domain talks about x values, which are left and right. Now our range, our graph doesn't go higher than 1 and doesn't go below -1. So our range is from -1 to 1. That changes when the amplitude changes, but we'll see that when we start to graph them. The amplitude is going to be the maximum and minimum height of the graph. So this number up here and the number down here are going to be our amplitudes. That's how high our graph goes and how low our graph goes. And then each function is periodic, which means that the graph has a repeating pattern. The shortest repeating pattern, or the shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is called the period. So in our sine graph, if our graph starts at 0, it follows the pattern that it goes up and then down and then back at 0. So that would just be one cycle there, or one period. Goes up and then down and back at 0. Now this pattern repeats forever, pretty much. It goes up and then down and then back at 0. This would be another cycle. Good morning. It has a cycle in the other direction too. It goes down, then up, then back at 0. That would be another cycle. So it just repeats the same cycle again and again. But one cycle, or one period, is just the shortest pattern. So that would be from 0 to 2 pi. So just that pattern one time. So cosine does the same. But remember, we said cosine starts up at the amplitude. So here it starts at 1. And then it goes down and then back up to 1. So this would be one cycle of the cosine graph. It keeps the same shape as the sine, but because we're starting in a different place, our graphs are going to look a little bit different just because we are like cutting the graph in a different section. But it's the same shape, we just stop at a different place. So we're going to be given sine and cosine functions to graph. Sometimes we may have a number out front. This number out front tells us the amplitude. So that's just how high and how low we go. If there's no number out front, then you just go up to 1 and down to -1. But if you had something like 2, our graph would go up to 2, down to -2. And then whatever gets multiplied to x, this number helps us with the period. So our period is 2 pi divided by b. So that's the number that gets multiplied in front of x. We just take 2 pi and divide it by that number. So for every graph, we're going to be asked to find the amplitude, the period, and one other thing to help us graph is going to be the increments. So to find the increments, we take the period and divide it by 4. So these 3 things are going to be the 3 things that we need to find in order to start graphing. The amplitude, the period, and the increments. And for all of our graphs, each one is going to have 5 key points that shows the period. So notice here on our sine graph for one period, it starts at 0, goes up, back to 0, back down, then back to 0. So those are the 5 key points. So it just goes in between the 2 amplitudes. You don't go any higher than what your amplitude is, and you don't go any lower. And you only can go one space at a time. So we just go up to the amplitude, back to 0, down to the negative amplitude, back to 0. Same thing with cosine, but here we just start at the amplitude. So you start at the amplitude, back to 0, down to the negative amplitude, back to 0, back to the amplitude. So you're just going one space at a time. So these are what you would see your 5 key points for a sine or cosine graph. Okay, example 1. We have to identify the amplitude and period of our graph here, 4 times sine of x. Then graph the function and describe the graph as a transformation of sine. So we're going to be graphing 4 sine of x. So I'm going to draw my graph here. We want to find the amplitude, the period, and the increments. So the number that's in front of the sine, that's our A. That tells us the amplitude. The number that's behind the sine is the B. That helps us with the period. So what would our amplitude here be? Our amplitude's just 4, but we're going to go up to 4 on our graph and down to negative 4. So the number in front of sine tells us how high we go and how low we go for our graph. Now for the period is 2 pi divided by b. And b is the number that's being multiplied to x. What's being multiplied to x?
Is it always going to be that?
And b is the number that's being multiplied to x. Is anything being multiplied to x? No. So here b is just 1. So it's 2 pi divided by 1, which is just 2 pi.
How do we know it's 2 pi over b?
That's the formula from the last page. So it's always 2 pi over b, and b is the number that's being multiplied to x. If nothing's being multiplied to x, then it's just 1. So our period tells us what our last key point's going to be at. So this would be 2 pi. Now our increments tell us all the key points in between. So to find the increments, you take the period and divide it by 4. So what was our period?
2 pi.
2 pi. So 2 pi divided by 4 would be pi over 2. We just simplify. So our increment is going to be what each tick mark is. So we add that each time. So my first tick mark is going to be pi over 2. To find the next one, I'm going to add another pi over 2. So this is my increment, and I just keep adding that same increment each time to find the next one, the next one, the next one, because we cut our graph into just 4 equal parts to find the key points. So we're going to add another pi over 2. What's pi over 2 plus pi over 2? 2 pi over 2, which would be just pi. Perfect.
Wait, I don't
So we have to add another pi over 2 to find that third increment there. So that would make this 3 pi over 2. And then if we add another pi over 2, that would be 4 pi over 2, which is what? 2 pi, which is the end. So once we hit that period, we're done. We found all of our key points there. Now we just have to put the graph on it. So sine graph, does it start at the amplitude or does it start at 0? Starts at 0. So it's going to start at 0 here. It goes up to the amplitude, then back to 0, back to the negative amplitude, and then back to 0. So it just bounces in between the two amplitudes, but you can only go one place at a time. So we're going up to 4, back to 0, down to -4, back to 0. So it's just going to bounce in between the two. So this would be our sine curve. So I'll write that down. So whatever the increment is, that was pi over 2. So that's where we start, but we also add another pi over 2 to get to the next one, to the next one, and to the last one. So we add the increment. We need a common denominator, so I can make the first one pi over 1, so I can multiply the top and the bottom times 2. So 2 pi plus pi would be 3 pi. Yeah, so the formula for period is always 2 pi over b, and the formula for increments is always period divided by 4, always. Because you're just cutting the period into 4 parts to put your key points there. All right, let's graph cosine next. So we're graphing 1/2 cosine 2 pi x. So I'm going to draw my graph here. I need to know the amplitude, the period, and the increments. Awesome. The amplitude is 1/2. That's what gets multiplied in front. That's going to be like the first number that you see there. So amplitude is 1/2. So I'm going to go up to 1/2 and down to -1/2. Now period is 2 pi divided by b. What's our b here? 2 pi. So it's what gets multiplied in front of the x, which is 2 pi. So here we have 2 pi over 2 pi. What's 2 pi over 2 pi? 1. So our period ends at 1. Now for our increments, that is the period divided by 4. What was our period? 1. So 1 divided by 4. Just 1/4. So this is what we're going to be adding each time to get from one increment to the next. So we're going to start at 1/4, and then we have to find. So how would I find the next tick mark? Divided by 4, always. We add 1/4. So we keep adding that same increment each time. So we're going to add 1/4. 1/4 plus 1/4 would be 2/4, which simplifies to what? 1 over 2, 1/2. How would I find the next increment? Add another 1/4. So I'm going to add the 1/4 to the 2/4 just because my denominator is already the same. Just to make it a little bit easier for me. So we add the numerators together, we get 3/4. If you want to, you can add it again. Add another 1/4. What's 3/4 plus 1/4? 1. It'd be 4 over 4, which is 1, which is where we end. Perfect. So we added it right. Now let's put our graph on there. What color do we want to make the graph? Let's do red. So cosine, for our cosine graph, do we start at 0 or start at the amplitude? Start at the amplitude. So cosine always starts up at the amplitude. So next I'm going to move to 1/4. Where's my point going to go at 1/4? At 0. We've got to stop at 0. Where would my next point go? At the negative amplitude, down low. Where would my next point go? 3/4, but at 0. And then the last one? At the positive amplitude, at 1/2. Then we can draw our curve here, and it's going to look like that. The only difference is where you start. So cosine starts at the amplitude, the sine starts at 0. So your graph kind of looks different just because it's like a different section of it. But if I continued this graph with the same pattern, it would go like this. So it would continue, but it kind of looks, they end up looking the same, but it's just like a different portion of it. All right, on the next page, let's look at number 3. I'm going to draw my graph. I need to know the amplitude, the period, and the increments. The amplitude is 2. That's what gets multiplied out front. 2. So we're going to go up to 2 and down to 2. Down to negative 2. Now, period, what's the formula I use for period? 2 pi over b. And what's my b here? Pi. It's what gets multiplied to the x, so that is pi. So I have 2 pi over pi. So when we simplify, the pi's cancel, and what would our period be? 2. So we end at 2. So I have my starting key point and my ending key point. Now I just need to find all the increments in between. So there's going to be 3 more in between. How do I find the increments? Period over 4. So we have 2 over 4, which simplifies to 1/2. So my first increment is going to be 1/2. How do I find the next increment? Add 1/2. 1/2 plus 1/2 is 1. It would be 2 over 2, which simplifies to 1. How do I find the next increment? Add 1/2. So this would give us 3/2. How do I find the last increment? Add 1/2, so that would be 4 over 2, which is 2, which is where we stop. Any questions on the key points that we just did? All right, let's put our graph on it. So a sine graph starts where? Starts at 0. So we're going to start at 0. Where would I go next? Up to the amplitude, up to 2. Where do I go next? Down to 0. So at 1, we go down to 0. Where do I go next? Down to negative 2, and then back to 2. Then we can just connect the dots with a little sine curve. All right, lastly, let's do number 4. I'm going to draw my graph. I need to identify the amplitude, the period, and the increments. What would my amplitude be here? 1/3. Perfect. That's the number out front. So I'm going to go up to 1/3 and down to -1/3. How do I find the period? 2 pi over b, which is 2 pi over 1/2. Oh no, what do I do when I have a fraction inside a fraction? No. Keep, change, flip. Keep, change, flip. We keep the top, change to multiplication, and flip the denominator. So instead of 1/2, it'd be 2 over 1. So this would be 4 pi. So our period ends at 4 pi. We keep, change, flip when you have a fraction and a fraction. You guys got to know that. How do I find the increments? We take the period and divide it by 4. So 4 pi divided by 4 is pi. So our first increment is at pi. Got to find 2 more. How do I find the next one? What do I do? Add pi. We just keep adding the increment. I add another pi. So pi plus pi is 2 pi. How do I find the next one? Add pi. 2 pi plus pi? 3 pi. And then if we add another pi, we get 4 pi, which is the last one. Now that we have all of our increments there, we can go ahead and graph. Cosine starts where? Starts at the amplitude. So we start up at 1/3. Where would I go next? Back to 0 at pi. And then at 2 pi, where would I go? -1/3. At 3 pi, where do I go? Back to 0. And at 4 pi, where do I go? Back to the amplitude, back to 1/3. So every graph is going to have 5 points. If you are missing a point, you did something wrong. And it's always going to start at the same place that it ends. So this would be our cosine graph.